Hi, this is Vivian Labbot and this is CS6105, Discrete Mathematics, and I'm going to try to solve the course project number 1. So let's start with the activity 1. So activity 1 is translating English sentences to a statement in propositional logic. So, okay, let's start with this problem number 1. It says here that if prescription antibiotics or any antibacterial medicine do not work to kill viruses, then they will also not work on COVID-19. So let's denote A as antibiotic, B as any antibacterial meds, and C would be the COVID-19. So as we analyze the problem, this is a not or negation statement, and it says here that A if A if not A or not B, then it is also not C. So same with this. If this one doesn't work, uh, sorry, if this one doesn't work, then this one or this one doesn't work, then it won't work as well with the COVID-19. So it's just the same with this. If not A or not B, then it's also not C. And let's go to problem number 2. COVID-19 infection may be transmitted if and only if you are in close contact to an infected person or you are not protecting yourself. So this statement is an if and only if statement. So let's denote again A as COVID-19, B as close contact, and C as protecting yourselves. So it says here that you will be infected with the COVID-19 if and only if you are in close contact or you are not protecting yourself. So we will write the statement like this. So A is true. So this one, A is true if and only if you will use this sign. If and only if B is true or not C is true. Okay. And let's go to activity number 2, proving if two sets are equal. Using the listing method in the membership table. Let's use first the listing method, and this is the given. We have 4 propositional logic here, propositional variable, I mean, and the universal set, set X, set Y, and set Z. So these are the given. And then, okay, let's try to do the listing method first. So we've been asked to prove this statement: the X union with the intersection of Y and Z is equals to the union of X and Y intersect with the union of X and Z. So let's evaluate first this first statement or proposition, and of course we have to deal first with this variables inside the parentheses, and yeah, we have this given, and the elements of Y are 1 3 6 9, and Z has an elements of 2 3 5 7, and let's get the common elements that they have, because they are it's asking, it says here the intersection of Y and Z, so we have to get the common elements that they have, and they only have 3, so this one. And then after that, then we will evaluate this the union of X with this. So the elements of X are 2 4 6 and 8, and then union with 3. So we will just copy it, since this one is not common in any elements inside the X set. So we'll just all copy it. So we have 2, 3, 4, and 6. 6. I'm sorry, 6 and 8. And then next is we are going to evaluate this statement or proposition, and we have to get the union of x and y, and then the union of x and z, and then after that, then we will solve for its intersection. So first, let's evaluate this one. The value of x is this, and the value of y is this, and then we are going to copy all the elements that they have. But if they have common, then we'll just write one. So like this, for example, this one, the 6. 6 is also available, present in the y elements of y. So we will just write 1, 6 here. So we have 1, 2, 3, 4, 6, 8, and 9. And then let's also evaluate the union of x and z, which we'll just do the same process as what we did here. So we'll just copy all these elements that they have, and then if they have common elements, then we'll just write 1. So we have this. And then after that, then we will evaluate their intersection. So we will find what are the common elements that they have. So based in our answer here, we are going to check if what elements, what common elements that these two have. So this one, 2, we have 2, we have 3, we have 4, we have 6, and 8. So therefore, we are going to check if the value that we got here is the same as the value that we got here. So it's pretty obvious it's the same. So that means we prove that this proposition is true. So let's try also to do it with the membership method, this one. So what I did here is I say based on the universal set, I've instead of writing this, because we cannot solve this problem if we are going to use these numbers, we have to translate it into the true or false statement, or the 1 and 0s, because that's the variables that our elements that we are going to use in membership method. And to do that is we have to check if the variables and universal set is available in the elements of x, y, and z. So I mean the elements in universal set, if they are all present in the elements, or yes, if they are present in the elements of x, y, and z, that means it's true. But if it's not, then that means it's false. So let's try to do the x first. So here we have elements of 1, 2, 3, 4, 5, 6, 7, 8, 9 in universal sets. So let's check if all of these elements are in x variable. So since 1 is not, then we will write 0. Since 2 is there, so we'll write true, means it's true, so we will write 1. And then 3, 0, because it's not available in x variable. And then 4, it has, so it's 1. 5, it doesn't have, so it's 0. And then 6, it has, so it's 1. 7, no. 8, it has, so it's 1. And then 9, it's 0, because it doesn't have 9 here. So same true with y and z. We are going to do this. We are going to do the same process. So just check if all the numbers here in universal set are available or present here in the x, y, and z variable, and then just if there is, then that means it's true. If there's none, then that means it's false. So 1 is equals to true and 0 is equals to false. So then we're going to evaluate this one. The proposition y intersect with z, the intersection of y and z. So we are going to base it with the elements that we have concluded from here. So y intersect with z, so we'll use this one. It says here that when using the and or the and, the principle of and is that if one of the elements inside of any propositional variable is false, then the statement is false. Otherwise, it's true. So since one of them is false, then the statement is false. Since and then next is also false, since there is one false. And then this one, it's both true, that means it's true. And then so this one has true values, so that statement is true. This both has true value, then the statement is true. This one has both false, so the statement is false. And then this one has only one true, so it's false. False here, false here, false here, false here. But here it's the opposite. If you are going to find the or, this one, it represents the or here, or the union. And then we are going to use the or statement, which the principle of or says at least one of them is true, then the statement is true. But if both of them are false, then otherwise it's false. So we are going to get the union of x with this proposition. So from here, since x is 0 or false, and then this one also is false, then the statement is false. And then here, since x is true, and although this one is false, still the statement is false. True, I mean, sorry, it's true. Same true with here. There is one, at least one of them is true, then the statement is true. Also here, but here they are both false, so they are both false, this one and this one, so that means it's false. And then this one, at least one of them is true, then it's true. And then same true with this, and so on. And then next we're going to evaluate the second statement, or the second proposition, and this one. So we have to find first the union of x and y, and then next is the union of x and z, and then this one. So based on the values of x and y, we have this answer. And then based also in the values of x and z, we have this answer. And then also to get this one is we have to check the common, or I mean the end statement. We are going to use the end statement here to find the values of this. So like what we did here. So as we can see, it's we are going to compare this one, the value that we have taken here, and in this one they are the same. That therefore we have proven that this proposition is true. And I think that's it. And thank you.